Good afternoon. It's a pleasure and a privilege to be here, and I appreciate everyone's attention. I'm following some outstanding presentations by my colleagues, and I think what I'd like to try and do today is illuminate for you the emerging and developing field of cellular medicine and speak specifically about the work that we've been doing to deliver these therapies in formats that can address these global health threats. Now, you've heard this morning that some of the things which challenge us include infectious diseases, but keep in mind that cardiovascular disease, neurodegenerative and cognitive decline, as well as immune dysfunction, all contribute to a risk to the overall population of premature mortality and morbidity. The other thing which you should all keep in mind is that lifespan in society is as important a predictor or indicator of societal success as anything else. And as we're trying to push the envelope and increase the number of years we live, we have to maintain high performance during those years. So cellular therapy is an opportunity to deliver a tool that augments or replenishes the reservoir of stem and immune cells within the body in order to enhance biologic functions during disease and aging. These cells can actually restore the natural protein and transcriptome products that are necessary to produce structural, enzymatic, and other components which are necessary for health. Replacement of these defective cells can actually restore function in organs and tissues and can ultimately change the physioanatomic state of an individual. So what's a stem cell? We all know that stem cells start out as that totipotent form that exists early after fertilization, and then as the cells divide, they give rise to cells which have the ability to replace themselves and differentiate and specialize into different parts of the body and tissue. Now, many years ago, when I was a young surgeon, I became interested in the concept that the regenerative potential that resides in utero is almost infinite. This photograph depicts fetal surgery where, based upon a prenatal ultrasound, a condition called spina bifida was detected. And we had the opportunity to actually open the womb at 2 or 3 months of gestational age, expose the fetus, repair the damage to the exposed spinal cord, put the fetus back into the womb, and within 4 to 5 months, when that infant was born, it had no evidence of a scar. That got us thinking that there might, in fact, be a remarkable resource that resides in the leftovers of full-term healthy pregnancies. And I often refer back to the story that when my oldest daughter was in utero, I noticed for the first time that although she was just a peanut-sized embryo at a few weeks gestational age, her placenta had already developed into a relatively large organ. Now, that means that the placenta is actually nature's stem cell factory. It is also unique in that the immunologic relationship between the placenta and the mother that carries it is remarkably allotolerant. What that means is that every placental cell can be accepted by another individual without rejection. This makes it a remarkably valuable tool for this emerging field of cellular medicine. In addition, the placenta, and in the world today, 130 million of these organs are disposed of, the placenta is also a source of remarkable biological materials that can be used for tissue engineering. Now, several years ago, along with Craig Venter, the first scientist to sequence the human genome, we founded a company that was directed at identifying those genomic traits attendant to long, healthy life. And during that time, Dr. Venter's view of the world is that DNA, that material that makes up our genetic code, is nothing more than a programming language. And if you think about it, if the DNA that resides in the nucleus of every cell is in fact a programming language, you could actually conceive that every stem cell is like a small computer. with the nucleus holding the software, the cytoplasm holding the processor, and the cell surface, the cell membrane, acting like the keyboard or the I/O, input-output device. Now this means that every stem cell, when administered to a recipient, may act like a master boot disk, may in fact be able to reboot the software that resides in that individual. So if software becomes corrupted with age or disease, the potential to use stem cells to repair or restore function of that software is one of the potential tools for these cells. Now, at our company, Celularity, we have a broad range of cell therapy programs. This is just highlighting some of them. But I want to talk specifically about some that have relevance to the area of infectious disease, namely immune cells that are derived from stem cells, as well as pluripotent cells, which can be used to restore regenerative potential, or that ability to renew, renovate, and restore the quality and the quantity of organs and tissues. What you see here is that our focus today is in areas like immuno-oncology, using immune cells to combat cancer, as well as using pluripotent cells to restore regenerative function. And we're even recognizing that some of the components of these cells, namely the fragments of cells called exosomes, might even afford us a new way to deliver these therapies. The transformative approach that we take takes full advantage of the placenta's unique allogeneic ability. So allogeneic means that you take a cell from an unrelated individual and put it into another individual, and it is tolerated. What's unique about the placenta is it's nature's professional allograft. If you think about this, every mother is the source of 50% of the genetic material that resides in the developing fetus. That means she's a 50% match to the tissue type of that individual. Yet she does not reject the developing fetus, the fetus doesn't reject her. Well, consider in surrogate pregnancy, the mother is not even related to the developing fetus, yet she carries that fetus for 9 months without an immunologic response to it. That fundamental immunologic relationship actually is conserved in the cells that we use as therapeutic products. Now, how do you ultimately reduce this to practice and deliver it to patients around the world is you've got to meet certain criteria. Among those, you have to have access and affordability of products, you've got to have reliability, and you have to demonstrate efficacy and safety. This triad, if you will, is at the cornerstone of being able to democratize cell therapy for the world. And if you consider this, I mentioned before that 130 million placentas are discarded a year in the world. This means this is potentially the greatest resource for biological material for this field and for others. So let's talk about how we use this in clinical applications, augmented immunity. So our approach, simply enough, is that when an individual's immune system begins to function abnormally, what are the consequences? Well, you heard from my colleagues earlier today that some of those consequences are serious infectious diseases, okay? And there are countermeasures such as antimicrobials, vaccines, et cetera, that are very, very useful in that fight. However, we recognize that in some cases, a new approach or a supplemental approach might be to actually enhance or augment the immune system of an individual by delivering immunocompetent cells from another source. So, what we recognized was that there's an interesting observation we made that 1 in every 1,000 pregnant women, 1 in every 1,000, has some underlying malignancy during pregnancy. Does anyone want to venture a guess as to what the rate of transmission of that cancer from the mother to the fetus is? It's essentially 0. Never happens. Now, why is that? Why is that? Metastatic disease, especially in a heavily vascularized organ, has a very, very high rate. Well, it turns out that we went looking for the reason that these cells were protected, and found that there was a unique natural killer cell that resided in the placenta that not only had an anti-cancer effect, but also had a remarkable ability to protect the newborn infant immediately postnatal. So if you think about this, a fetus develops in essentially a sterile bubble. right? And then at the instant of birth, it's deposited into the ambient environment that's filled with pathogens. And although it hasn't had a chance to develop any significant adaptive immunity, okay, it's these cells protected in that early phase of life. So we recognize that placental natural killer cells may in fact be one of the greatest tools in enhancing an individual's response to not just cancer, but also is a response to infectious diseases. And placental natural killer cells can directly via what we call cytolytic granule-mediated effects, as well as indirectly by stimulating immunoregulatory molecules that help boost the response, can in fact be an ideal way to augment the immune response in an individual. And these natural killer cells do not cause any type of alloimmune reaction. Patients don't develop graft versus host disease. They don't develop a significant response against their own tissues or organs. So augmented immunity in treating inflammation and age-related diseases is also a great opportunity. And if you remember from the first slide that I put up about what the global health threats that we're facing, among those were cardiovascular disease, neurodegenerative disease, and so on. Each one of those is a potential target for modulating inflammation, since inflammation is at the heart of all of those degenerative processes. So our approach, which we call the placenta-derived allogeneic cell therapy approach, or PACT, is that we deliver cells that are allotolerant, meaning they can be delivered one size fits all from any donor to any recipient, and then we productize them so that they can specifically target mechanisms that are at the heart of the individual disease or process. So in the regenerative medicine world, this means that these cells can suppress inflammatory processes while stimulating pro-regenerative effects. And in an area that I've had an increasing interest, the diseases and the degenerative processes associated with aging, this in fact might be one of the easiest tools we have at our fingertips. So let's talk a little bit about aging and longevity, because this is an area that we have increasing interest in and experience in. So the good news is that across the world, lifespan has dramatically increased over the last 100 to 150 years. It's roughly doubled. In the United States, this has been marked by very specific historical events, mostly related to breakthroughs like sanitation, antimicrobial therapy, the advent of greater detection for cancer, and so on and so forth. But with increased lifespan, there comes a price to that. And that price includes chronic diseases, degenerative diseases that affect the cognitive function, and most importantly, this process which by we lose our strength, a process called the development of frailty. Now, older adults are at very, very high risk for chronic illnesses like cardiovascular disease, pulmonary disease, or cancer. 80% of Americans over the age of 65 have at least one of these. Okay? Now what that does is that severely limits their ability to be productive members of society, and it also dramatically affects their ability to have a livelihood which maintains their financial health. That's something to consider as well. Now the thing which is on the minds of everyone in healthcare in the United States is that dementias are becoming increasingly common with age. And if you look at these numbers, by the time patients reach 80 years of age and beyond, a third or more have some evidence of a chronic cognitive decline, which can be characterized as a form of dementia. That means that if we add years to these folks' lives, but don't address this problem, they will continue to be a severe burden to society, and they certainly will not be able to enjoy the benefits of those extra years. So the biological hallmarks of aging illustrated here are all related to fundamental genetic instability, the inability of that genetic material to properly encode for and express the protein products that are necessary for functionality of cells and for tissues. And as I mentioned before, if that's what the problem is, maybe one of the easiest ways to address it is to reboot that software, okay? And if you look at epigenetic effects that are found and identified in aging, we already know that it's the chronic exposures to chemicals, viruses, radiation, and so on that make subtle changes to the DNA in every cell in our body, but the ones that are most sensitive to this are the cells that make up our stem population or stem cell reservoir in every organ and tissue. So if those things are being corrupted, if that software is being corrupted slowly over the lifetime of an individual, we have to address that and find some way to restore the integrity of that information. And this bottom line is that if you look at this graphic right here, this translates into a tremendous opportunity to address age-related decline on the basis of restoring the integrity, quality, and consistency of the expressed genetic products from that biological software. And it's interesting enough, but even subtle changes to an individual's genome, even subtle changes can be reflected in significant functional alteration of the expressed proteins from those cells. Now, we started to look at this more closely and say, is there a correlation between the number of stem cells in an individual and their age and their ability to maintain health as they age? And sure enough, we identified that there is a rapid decline in the number of cells that occurs with age, and that it's not just the quantity of cells, but it's the quality of those cells which declines. And if you think about this, this correlates specifically to changes in functionality in every organ system, and it represents for us a very, very interesting window of opportunity to administer regenerative therapy. So several years ago, when looking at data from a number of clinical trials we were doing at our company, we recognized that in one organ system, bone marrow, if you quantify the number of stem cells that reside in bone marrow and you correlate that number to age, there is an exponential decline in those numbers as age-related. And when we actually looked at even patients who had certain diseases like hematologic malignancies, the correlation was even closer. So the sharper and the faster the decline in the stem cell number in bone marrow, the less healthy, the less disease-resistant that bone marrow is. We decided to look at this in a more comprehensive way. I'm actually here with one of my colleagues, Dr. Solorzano, who actually helped me do some of this research. And we actually showed that in virtually every organ system in the body, there is an age-related decline in the number of stem cells, and that decline is also associated with a functional decline. So the obvious question to ask is, well, if it's simply a numbers game, what if you boost the number of stem cells in an organ or tissue? What does that do? So we embarked on a quick study where we took subject animals, we collected stem cells from birth, from their placentas, we processed and stored those cells away, and then we gave them back doses of their cells every month from the time they reached sexual maturity. And what we found was a remarkable correlation between that number of stem cells administered back and the lifespan of the individual. Animals who got their stem cells back lived 30 to 40% longer than their litter mates. Okay? So just think about what that might translate into for human beings. So at the end of the day, the physioanatomic changes that occur with age reflect a continual renovation of tissues by an ever-declining quality of stem cells responsible for that renovation. It's sort of like trying to renovate a building or a home. If the quality of the materials you use to renovate decline in quality, over time, the quality of the finished product declines as well. So for us, this represents a unique opportunity to recharge the regenerative engine of every individual by administering back stem cells that are collected at birth from an organ like the placenta, preserved so that their genetic integrity is not changed. And the best way to do this is by cryopreservation. and then over time recharge the system that's responsible for renovation and repair of the organ. So our placental-derived allogeneic cell therapy approach in longevity is simply enough to recognize, quantify, and identify those specific systems that have been degraded by a decline in the quantity and quality of stem cells and boost those numbers back up. So this is a paradigm shift in using cell therapy in everything from cancer, inflammatory disease. I think I shared with you the opportunity to use this in infectious diseases. But what's most exciting, and actually is relevant in environments like the Emirates here, is that we can address age-related diseases and decline by using the same tool. So thank you very much. You can also contact me through the Twitter address right here. Thank you very much.